Alright, so today we're going to talk about filtering in Betaflight 3.2 and higher. Okay, so if we go into Betaflight and go into the PID tuning tab and we select over to the filters tab, there's a whole bunch of filters here. And a lot of this filtering we can adjust and turn off. What's important to note about filtering, this soft filtering, which is software filtering, is that it all adds latency. So it's a handoff. One thing is good, that you can reduce the noise that your PID loop is seeing from your gyro. But on the other hand, it's delaying the information, basically, that's going to the PID loop. And that delay in information, for example, if you have prop wash, it's happening very fast. So if you then step back the information a couple milliseconds, it's very hard to handle prop wash if the information you're getting is out of date already. Whatever reaction your quad's going to give to address the prop wash is already out of date if it's delayed significantly by filtering. On the other side of it, you can't really get a good tune on your quad until you can address noise significantly enough to have a high enough Dterm. And if your Dterm's not high enough, you're not going to be able to address prop wash. So you can see on one end you need to address the noise, on the other end if you implement too much soft filtering that can add too much latency. So on Betaflight 3.2 and higher, the first thing you want to do to address noise is soft mount. If you have a lot of noise in your quadcopter, you want to really soft mount your gyro. And usually that comes through soft mounting your flight controller, and then the second step might be soft mounting your motors. So I'm going to link to a document I have below on really the step-by-step guide to attacking noise, from my opinion at least, and how you want to step through that, and it outlines what introduces latency and what does not. In this video we just want to talk about the filters and what they do. So I'm going to pull up Black Box for an existing flight, and I'm going to look at this because it's a good illustration on filtering itself. But before we look at each of the filters in Black Box, let's just look at the filtering sequence. So we have the gyro itself. Then after that we have some debug modes, which you can pull noise, you can see the raw data from the gyro and report that in Black Box. And you can only do one at a time, so you either are going to report debug mode gyro raw, gyro notch, or I'm sorry, just notch, FFT, which actually does report on channel 0 pre-dynamic notch and on channel 1 post-dynamic notch, which we'll cover in another video. And then you have your debug mode as gyro, and then your debug mode as defilter, which unfortunately is not working right now in Betaflight. But going back up, so if you want to really see the raw noise on your quadcopter, you want to look at debug mode equals notch, and that gives you no filters. You can see the red here are in this graphic are the actual soft filters in Betaflight. So this will give us unfiltered scaled gyro data. The first filter, soft filter, all the data passes through is the dynamic notch filter. That's a new feature as of Betaflight 3.2.0, and as of this new feature they actually reordered the devs reordered the gyro sequence. It used to be the low pass filter first. Actually, the low pass filter was one of the ingenious things of Betaflight as it broke away from Cleanflight. It was the introduction of the low-pass filter, so this was first. Then later, in 3.0, static notches were introduced. Now we have the dynamic notch. So these things have changed in order. The gyro noise used to come down to the low-pass filter, then the static notches, and then out to the PID loop. But now we have the dynamic notch. So the dynamic notch is great. You want to make sure that that's enabled. So to go into Betaflight and look at that, you go to the Configuration tab, and you slide down to the features set, and in the features set you can enable the dynamic filter right here. You click that on, enable it, and hit save and reboot. After the data passes through the dynamic notch filter, which we'll talk about what that does in a second, Then it can pass through some static notch filters, which essentially at this point are old. The dynamic notch really replaces the static notches because it does the same thing, but it moves around, it automatically updates, where the static notches you had to set yourself. Then the low pass filter, the tried and true low pass filter, is always there and still recommended to have on. Then the data passes into the PID loop calculation and then outputs the P, I, and D values for the motors. However, before the Dterm goes to the motors, it can go through an additional 2 filters to smooth out that, basically the input to the motors, smooth out the trace if you look in in black box before it goes to the motors. So this little pictogram hopefully helps you understand, the sequence of things that are happening and where you can pull out certain pieces in debug mode to take a look at them. So in this log, which is an old log, an old flight, but nevertheless, it has all the filters turned on. So it has the dynamic filter turned on, which you don't really see anything for that graphically, but it also has the static notch 1, static notch 2. Make sure you caught that. Static notch 1 is actually higher on the frequency scale. Static notch 2 is actually lower. Has the Dterm notch, and then your 2 low pass filters, one for the gyro low pass and one for the Dterm low pass. So in modern, the modern versions of Betaflight, the recommendation is to just really turn off the old static notches. But they are there, and as you saw in that graphic, are available to calibrate to wherever you have noise and utilize in addition to your dynamic notch. So let's just step back for even a second here and look at what do these different filters do? What do they look like? So I'm going to drop this link in the description below, and you can see what a low pass filter versus high pass filter. So you'll see low pass and high pass filter. There's no high pass filter in Betaflight, and also a band pass versus band reject filter. So low pass filter, let's focus there first. So the low pass filter in Betaflight is essentially described herein, and I'm going to drop an audio clip here in a second on what that essentially does, because you can apply the same filtering to even your voice. So check this out. So take note in this voiceover example that they start with a low pass filter at 10 kilohertz or 10,000 hertz, and they end at 250. And notice how quiet it is at 250. Betaflight's low pass filter is at 90 hertz.
This is my voice, unprocessed. This is my voice through a low pass filter with a cutoff frequency of 10 kilohertz. This is my voice through a low pass filter with a cutoff frequency of 5 kilohertz. This is my voice through a low pass filter with a cutoff frequency of 2.5 kilohertz. This is my voice through a low pass filter with a cutoff frequency of 1 kilohertz. This is my voice through a low pass filter with a cutoff frequency of 500 hertz. This is my voice through a low pass filter with a cutoff frequency of 250 hertz.
So looking at a low pass filter, what a low pass filter is in Betaflight, and I ignore the high pass filter. Betaflight does not use a high pass filter. But essentially that low pass filter, you'll see that frequency cutoff. So you see cutoff frequency here. Well, that is the same thing that if you go to in your black box logs or in Betaflight, you'll see that gyro low pass filter cutoff. And you can see at the cutoff frequency itself, in this log it's at 70, and in Betaflight's default it's at 90. So at 90 is the default. That you're already attenuating about 3 decimals, and then afterwards it slopes down and reduces noise even further. A good resource to look at is the gyro and Dterm filter recommendations. If you come down to almost the very bottom, you can see the delay associated with each low pass filter. So taking a look at and trying to compare the filter slopes, I've come up with this. Essentially, this is a plot Joshua Bardwell published a year or two ago of the FIR filter. overlaying the PT1 and biquad on top of that based on information on the wiki for Betaflight. I'm coming up with these slopes for the biquad versus PT1. So you can see the fur filter has this essentially the steepest slope, but has a limit. Once it gets down to about negative 20 decibel reduction, it kind of bounces around there and honestly goes up from 25 to 20. The biquad has a steeper cutoff or transition band, and the PT1 has the most shallow. So one of the things that comes to my mind is if all the noise down here between 0 and 100 is useful motion noise here for the quad moving, and any prop wash noise can transition anywhere from 20 up to possibly even close to 100 hertz. Why would we not use the biquad filter at a minimum, and maybe even the fur? What's handy about the biquad and the PT1 is these keep going, so these keep canceling out noise. So once you get into the much higher frequencies, it's basically irrelevant. Keeping in mind your motor noise is right about here. So why wouldn't we not just use a biquad and set it higher for the low pass cutoff frequency on it? Well, the rub is that the biquad filter has more latency across the entire band. So if you're looking at the biquad filter and you have it set at the cutoff at, let's say, 90 hertz, which is the default, that means any noise or any motion of the copter or anything has a 2.5 up to 2.75 millisecond delay. And as you can see, as you set the cutoff frequency higher, that delay of any of the motion, any of the prop wash, so on and so forth, goes down some, but you're still at the minimum going to be, and this is honestly unrealistic to set it at 170, but at a minimum it's 1.25. Well, if you come down to the PT1 filter, you can see you start at around, the highest for the cutoffs being set at 90 hertz is around 1.3, 1.35 milliseconds, and then it goes down from there. So any of your motion of your copter or any of the prop wash is not delayed near as much as it would be for the biquad. So that's the rub, that we could use a steeper filter line, but then you're getting more delay across the entire spectrum. And for more details, just slide up to the what is the difference between a PT1 and a biquad filter, and you can hear it right from the devs. There's also some great information as you slide down through this on setting your low pass filters, where you should be setting them, how you should be using them against notch filters, which is a little less relevant now that we don't have static notches and you have a dynamic notch, but it's still relevant for the Dterm notch filters. Now moving on down to the notch filters. So in this website, they don't call it a notch filter, they call it a band reject filter, which I think is really the general term. I think the notch filter is a Betaflight term. But essentially you have the stop band is in the middle, the center frequency of the notch. Then you have a breadth, or basically a width where the transition zone is, and anything above it passes straight through, or below, anything below it passes straight through, and anything above it. So it's attacking a specific area of noise. Essentially, if you're looking at a black box log, it's the inverse of the noise you might be seeing from your gyroscope. So you can set the center right over top of this noise, and then have your cutoff, your transition zone through here. Maybe your center is 160, your transition zone ends, and your cutoff stops at, 115, 120. And then anything above it passes straight, or below it passes straight through, and above it passes straight through. And what's the purpose of this? That's so you don't have to push back your low pass filter so far to cut off this noise. Because the farther you have your low pass filter pushed back, the more latency it provides. However, if you can just directly attack a couple things, essentially for quads, the motor noise, with a notch filter, then that allows you to bring your low pass filter up higher in the hertz range, which introduces then less latency to the data getting to the gyro. So that's why both work hand in hand. As you can see, notch filters, as another graphic here, they have about 0.6, at the max, and this depends on, so this is a breadth of a notch filter of 80 hertz. So it's 80 from the center point frequency, where you're ever setting the center of the notch filter. There's 80 hertz down from there, and then it also replicates 80 hertz above that center frequency as well. So it's 160 total is the total width, and you can see where they're setting that notch. This is at 220, 230, 240, so on and so. So you're looking about a 0.6 millisecond lag in the data. So coming back in the Betaflight, what we were just talking about is the gyro notch center frequency, which we were talking about in that example. With the chart was up around 200, 260, I think it was, and then they had an 80 hertz for the notch cutoff, and then it was 80 hertz above that. So whatever you place below it, it goes above it. So that's for the static and the Dterm. So this is a fairly noise-free craft. That's not too bad. You have but this is all this noise here you see is pre-filtered noise. This is on the debug node equals gyro, and we're looking at the pitch axis. So you have this is the motor noise spike of it. The dynamic filter is turned on, so you can see here. So that's good. And the two static notch filters are turned off. So what could this person do to increase the performance of their craft? Well, if you look in the black box log, there's still a lot of Dterm jitter, or essentially overactive Dterm, especially on the pitch axis. If I run that spectrograph, you can see there's a lot of Dterm jitter here. So what's that coming from? Well, some of this noise on the pre-notch for the pitch, that's getting through to the gyro. So if I run the gyro trace for pitch, you'll see, the dynamic notch is doing a heck of a job. Look at it cut, how much it cuts it down. But you can see some of this is still getting through. So what can we do? Honestly, I would let that pass through like it is, and just center. You can see this Dterm notch filter is not centered over that noise. So that should be moved down to around 160 hertz for the center, and then also set the cutoff. So the center would be 160, and the cutoff would be around 110. That's going to narrow up that notch filter as well. Right now it has a breadth of 100 from the center. You can see the center is actually just off the graph. This goes up to 250. The default is 260. So it really has a breadth for half that notch of 100, 200 in total. That's going to narrow that down to make it less latency. And we'll also just directly attack this noise, because this noise isn't causing an issue on the P term. You can see the P term is pretty good. So if you had a lot of vibration on the P and the D, then you'd want to attack the noise directly on the gyro. But if your P and I looking pretty good, specifically the P, and it's just your D term, well, that's where you want to use those D term filters. Now, coming back to this little pro tip, your prop wash is occurring from 0 to 100 hertz. So this noise in here, this motion that the quad's detecting, on a normal flight, you're just flying around exploring, you shouldn't have any noise in this range. It should all be down here around 10, from 0 to say 20 hertz. But if you're doing aggressive moves and you have prop wash, that prop wash noise, or that prop wash motion that the quad needs to attack, is here between 0 and 100. Hence why the low pass filter needs to be above that for the quad to address this. And if you have too noisy of a quad and you want to start pushing these down, well, it's going to be very difficult then to address prop wash. Another thing that I would consider in this log is moving down your D term low pass filter. So yes, as we move this down, it's going to introduce some latency. So obviously if it gets worse, you would put it back. The first thing I would do is bring the notch down. That's going to introduce less latency and address that noise, so you can move that Dterm up higher to address bounce back and prop wash, because you're killing out some of the noise on it. And moving your Dterm low pass filter down to address this noise, so we can get at least a 3 decibel quieting of that noise. Really the recommendation with this current release of Betaflight is to turn off your static notches holistically. So you'd want to go into your PIDs, into your filtering. You'd turn off static notch 1 and 2, because now you have the dynamic notch turned on. By default, your low pass filter is a PT1 low pass filter for now, and you can increase that or decrease it as desired. If you have low end noise, you can increase that, but you're going to get more noise. I was helping a gentleman with a larger quad, so he's not doing a lot of aerobatic moves with it, and he, since you're not trying to deal with tight turns and prop wash on large 10-inch crafts, he can move that low pass filter down. Ironically, if you move over to iNav or GPS-based software for larger crafts, their filtering is set much lower than it's set in Betaflight, because they're tendering to larger crafts that aren't trying to race around gates and things of that nature and fly over trees inverted and all that kind of stuff. Coming down then to the Dterm, the recommendation as well is to set that to PT1, and then if you can, to also disable the Dterm notch filter. However, before you do any of that, you need to do it a step-by-step guide. There's plenty of guides on the internet and YouTube. Go check them out on doing a step-by-step of turning off your notches, and then also before you turn off your Dterm notch, to feel your motors. And honestly, to me, if you're going to turn off some of your Dterm notch and your, there's really a recommendation to never turn off your Dterm low pass filter. That you really need to be into black box at that point to really have an assessment on that. So hopefully this gives a holistic picture of how this all kind of comes together, how the filters work, and if you have any questions, drop them down in the comment box. If there's a lot of questions, I'll do a follow-up video and try to clarify it some more. Thanks guys, and I hope this helps.